Hello everyone. I'm sitting here in the dark because I'm going to be showing you a little demonstration with a flashlight, just so you know. There hasn't been a power outage or anything. Last week we talked about how energy transfers throughout the atmosphere through radiation, conduction, and convection. Recall that radiation is the transfer of energy through waves, like the sunlight coming down from the sun. The earth absorbs that heat, and then through conduction, which is heat transfer by contact, the overlying air that is in contact with the ground heats up, and then through convection, hot air rises because it's not dense, and cold air sinks because it is dense. Okay? Those three concepts come into play with today's lecture as well. We're going to talk about why weather happens, and one of the reasons is that the earth is heated unevenly, right? We know that the earth is a sphere. You can see that right here. We've got the sun's rays coming and hitting it perpendicularly, straight on, but it is hitting most perpendicular, right? It's hitting at a 90-degree angle right at the equator. Whereas, let's see if this works here. Whereas if I angle this, you're going to get light over a larger area, but the light isn't as concentrated as if I go straight on like this. I can show you another example of that. If I am shooting the flashlight directly at this board, you can see that there's a circle of light that's fairly concentrated, right? If I angle this, the light covers a larger area, but the flashlight is not putting out more energy in order to cover that larger area. The same amount of energy is coming out, it's just that it's spread out over a larger area, and that's what happens with the curve of the Earth too. We've got concentrated light coming right here where the equator is, and then as that light spreads out over a larger surface, it is not as concentrated, and so the areas of higher latitude, this is 0-degree latitude right here, the equator, going all the way up to 90 degrees, these areas don't get as concentrated of energy from the sun. Okay, I'm going to turn the light on so that I can see you. All right, so because of that, areas around the Earth that are closer to the equator are going to receive more solar radiation. They're going to receive more energy. So this area of Earth is going to have the most heat, right? Areas up here are not going to have as much solar radiation. So there's uneven heating just because of the line of latitude. Another source of uneven heating is the surface that the sun is shining on. So like water and sand or rock or dark rock, those all absorb and hold on to heat at different rates. And so you get all of these pockets all around the Earth that have different temperatures. They've got different humidity, they've got different wind speeds, and they've got different temperatures. And those chunks of air don't mix readily. They stay separate because they have separate characteristics. And that brings me down to this map right here. You can see that there's all of these different little blobs of color, all that have different labels on them. These are big, huge masses of air. They're called air masses. And that is just a volume of air that has similar characteristics within it. So this air mass right here has a different temperature and different wind speed and different water vapor content than this one right here. And we'll talk about what these letters mean in just a second. There's a lot of things that happen locally down at Earth's surface. Like in Little Falls, the wind can switch directions throughout the day, and maybe we've got a storm that hits some parts of Minnesota and not other parts of Minnesota. But when we really zoom out and we're talking about the high part of our troposphere, which is the layer that weather occurs in, we have these prevailing air chunks. I keep using the word chunk, but I don't know how to describe it in any other way. They're just big pockets of air that stay separate, and they have kind of the same characteristics. They keep regenerating, and the reason for that is that these air masses that are closer to the equator for one, are going to be warmer, right? Because the sun is beating down directly at the equator. Whereas up here at higher latitudes, we've got these blue volumes of air, and those are going to be colder because they don't receive as much solar radiation. Same thing down here. These letters talk about whether or not the air mass formed over water or over land. So for instance, this air mass right over Africa is closer to the equator, right? So it's going to be warm, but it also formed over land, so it's not going to have a lot of water vapor in it. Whereas right here, this air mass is going to be warm because it formed near the equator, but it formed over water also, so it's going to be a very humid and warm air mass. And these things float around. They stay kind of in the same areas, or they keep generating from the same areas, but they're constantly doing battle and running into all the other air masses. Okay, so like let's say this one rises, the wind blows this up here, the wind blows this one over here. Where they meet, where two unlike air masses meet, there's going to be a shifting, right? Because this warmer one, when it meets a colder one, is going to rise. And if the temperature difference between the air masses is really, 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 really great, it's going to rise quickly. It's going to rise violently. And that's where weather happens. Weather happens right at the boundaries between two unlike air masses. That boundary between them is called a front. So we've heard about weather fronts, maybe on the news when you've watched the weather. We're going to talk about what the different types of weather fronts are, and what weather fronts, what kinds of things happen when different combinations of these air masses meet. Okay? So what I'd like for you to do is learn a little bit more about these air masses and learn what all of these little letters mean by doing a air mass assignment. I've made a Google Doc that is attached to this assignment, and Google Classroom will make a copy of it for you. So you're going to open this up. You're going to go to this link right here, air masses. And then within the video, I think the video is like 8 minutes long. You're going to stop it at the 205 mark. You'll see a chart just like this in the video, and you're going to complete this table. So you're going to write down the word that each of these symbols stands for, and then what the meaning is over here. And then continue watching the video, and at the 6:15 mark, you'll see this map here. And it's asking you to write down what type of air mass is in each of these. And you can just type those in right over here. The video does give you the answers, okay? But see if you can pause it and see if you can get them right, and then play the video to check your understanding, and then you can go back and change them if you'd like, okay? This is just practice for air masses, and then go ahead and turn that in when you're done. And tomorrow we will talk about weather fronts. I hope you're well. I'll talk to you soon.